Hey, this is Mrs. Wheathy back for Unit 2, video lesson number 3 on the discovery of the nucleus. So in a quest to answer the questions from J.J. Thomson's plum pudding model, Ernest Rutherford worked with a group of scientists to see how alpha particles, these are positive particles, interacted with solid matter. So definition for alpha particle is positively charged particles released from the nucleus of a radioactive atom. And we'll learn all about that in the next unit. So he performed what is famously known as the gold foil experiment. And if we look at our diagram up here at the upper right hand corner, this is pretty much what it looked like. You had a fluorescent screen, so the inside of it fluoresced whenever it hit. If it had little dings hit on it, you would see like these little flashes of light. And in the middle of that screen, he had a piece of gold foil. Now, he used gold because it was made up of a single type of an atom. It was a metal, and it was solid. So, and that's what he wanted. He wanted a solid piece of something that was made up of a single type of atom. Now, in this lead-lined box, he had some radioactive material that released these alpha particles. So, it was an alpha particle emitter. And these particles were shot through a slit so that they were directed in a straight line. So here's what happened. There were 3 observations that were made. So you have this line of alpha particles were shot through this gold foil. And if the particles went through the foil, now remember it's solid, and basically you have this ray of light that, again, that's being shot through this foil. And if particles went through, then they would ding. You'd see these little flashes of light on that fluorescent screen. Now, why did he use positive particles? Well, they were looking for something positive in the atom. And through our electrostatic forces, we know that like charges are going to repel from one another. So there are 3 observations that were made. What I would like you to do is to stop the video and draw this diagram that you have right here. Do that now. Pause, draw the diagram, and then come back to the video so that you can write down the observations. Okay, now that you're back, the first observation that was seen, so this represents, the straight line right here represents the gold foil, and these arrows represent the alpha particles. So when he shot the alpha particles, what he found was that most of those alpha particles went straight through the foil. That was the first observation. Most of the particles went straight through. The second observation is that some of the particles went through, but they were deflected at an angle. Okay? They went through, but deflected at an angle. And then the third observation is that about 1 in 800 of the particles, so it's very, very few of the particles, didn't go through the foil at all, but shot backwards. Some straight back, some shot backwards at an angle. And so from those 3 observations, Ernest Rutherford made 3 conclusions. The first one, and each one goes with one of these observations. So why did most of the particles go through? What he concluded is that the atom is composed of mostly empty space. And that's why the particles, so you had all these gold foil, these gold atoms in the foil that were packed very close together. Most of the particles went through because they traveled through that empty space. The second observation that we see right here is that the positive particles went through the gold foil, but they approached very small dense area of positive charge. And what we know about like charges? They're going to repel. So as it approached that dense area of positive charge, going to be deflected away from that positive charge. So it went through, but at an angle. And then lastly, and think about this, why didn't some of them go through at all? And the reason he concluded, was that the positive particles hit dead on a very small, dense area of positive charge and shot backwards. Now, why could he say it was very small? Because 1 in 800 did this. Shot straight backwards, and he described this as being like holding a piece of tissue paper in front of your face and somebody shot a gun at you, and lo and behold, the bullet bounced off of the tissue paper and shot straight back at the gun. It was such a revolutionary moment at the time, quite exciting. And so what this did, or what this led to, was the discovery of the nucleus. Not the protons, but the nucleus, a very small area of positive charge within the atom, the nucleus. Now, through further experimentation, Rutherford and company, because there are a whole slew of scientists working together to develop the atomic structure, concluded that the nucleus contained positive particles called the protons that accounted for slightly less than half the mass of the atom. And that was important. Slightly less than half the mass of the atom, which was about 1.673 times 10 to the negative 23rd grams. So very, very small compared to the electron, which was times 10 to the minus 27th. So there was another question. And you can probably, if you thought hard enough, you could probably come up with some questions. So now we have why the atom is neutral. You have negative electrons, you have positive neutrons. But we now only have half the mass of the atom. So the big question is, what makes up the other half of the mass of the atom? And also, what contributes to the chemical properties of the atom, because that still has not been addressed. In 1932, James Chadwick, who was also a Nobel Prize winner, and so was Rutherford, he was a co-worker of Rutherford, and he discovered the neutron that has neutral charge. Slightly larger in mass than a proton, and so that makes up the other half of the mass of the atom. The mass of the proton and the mass of the neutrons makes up the mass of the atom. Remember that the mass of the electron is negligible, and this led to the third model of the atom, Rutherford's model. Please draw this in your chill. You have a small, dense nucleus, and in that small, dense nucleus you have the protons, which we show as a P with a positive charge. You have the neutrons, okay, which we show as N, and a superscripted 0 showing that it has no charge. This gives us the mass to the atom. Very small, very dense. Outside of the nucleus, you have this empty space, and within that empty space is the electrons, which we show as E with a negative charge. And the empty space, it is what gives us the volume, not the electrons, but the empty space. And let's write that down. So the empty space is giving us the volume, basically the size and the shape of the atom. Okay? And that